Hello, this is Ed Blomdahl again, and I'm making another video, as you can see. And really what I wanted to do was to list the scientific videos that I have made so everybody can see what I'm up to and what's going on, right? So I'll list out the 10 videos, and some are papers, some are partial papers, but the videos sort of explain what I'm doing, and to help you understand, I think where our science is headed, as far as I'm concerned. And I have a little blurb written down about it, and it might give you some more background. So if you haven't seen, maybe you've seen my first video about breaking the light barrier. Yeah, there's 9 others there that you can look at, and that's why I wanted to do this. It just shows up to this time, what I've been working on, and you can see plainly what I'm up to and where I think science is going to be headed, where science has to be headed. So I'm going to read and sort of interject at the same time. This one is for just the first video, which was breaking the light barrier, adding velocities beyond the speed of light. And I came across this attributed to Mr. Einstein, although I don't know if that's true or not. I'll get to that in a second, but it's basically a variation on a theme. They all go back to this sort of basic idea. Mr. Einstein came up with a different conclusion than I did, but I will state his conclusion, then I'll state my conclusion, and then you can think about it to see what's going on. If you read or have read any books by Richard Feynman, then you'll know where my title is coming from. Surely you're kidding, Dr. Blomdahl. So you can find a book that has that basic title, only with Richard Feynman, and the words are changed. So anyway, that's what it's about. So why don't we get started? So my first video that I have posted was breaking the light barrier, adding velocities beyond the speed of light. And I said the good news is that we are not imprisoned by the speed of light. Mr. Einstein came to the wrong conclusion from a thought experiment from his youth. The speed of light is the upper bound speed of the universe. This was based on the faulty conclusion that the speed of light and the motion of its source cannot be added. Yes, they can, and this is demonstrated in that video that I made. Also, since the Lorentz factor is simply a mental and mathematical constraint and has the entire, let me say, also, gosh, this thing's just knocking me over. Okay. Also, since the Lorentz factor is simply a mental and mathematical constraint and has nothing to do with reality, and since the Lorentz factor is used in every aspect of the special theory of relativity, STR, right, then the entire special theory is incorrect. Just like that, mankind is freed from the fetters of illusion. It may take a while, but the barriers to superluminal travel, superluminal, in other words, faster than the speed of light, will eventually come down. The barriers will come down. And then I sort of said, you can see in the video I did it slightly different, but the conclusion I came to is exactly the same. Right? If you're looking at, so here's a person with a mirror. For the time being, he can be stationary with respect to the source of a light, regular speed of light that's going out, and it can hit this mirror and then of course get reflected back. And let's say the mirror has 100% reflection, just to keep it easy, and we're trying to decide somewhat a few things, and also inelastic or elastic, right? Is it an inelastic collision or an elastic collision? So the light goes out, here's a man with a mirror, it comes back. This man sees it, who's a third-person observer. He sees it come back at the speed of light. Now, what happens if you're going to move? In other words, this person with the mirror is going to start to move. And you can just step it up. But, you can say just a speed, or you can say, 1/10 of the speed of light, or 20% of the speed of light, or whatever. So let's say this is going on, he gets to this point. This person with the mirror gets to this point, that it's, let's say, at 0.5, or half the speed of light. And you say, well, what's going to happen? Well, if we know this person is going at half the speed of light with respect to the source, right, and the speed of light is going out and coming back, but Mr. Einstein would say, well, that's not possible. In other words, you can't add those two together and get it to be greater than the speed of light. In other words, if we know this is half the speed of light, and we know that what the speed of light is, then the only way that you could get Mr. Einstein's idea to work is that the speed of light coming out of this is half the speed of light, but we already know it's at the speed of light. So that's not possible, right? That's not possible. You have to come up with you have to add it all together. You just can't come up and say, well, it makes no sense anyway, right? Half the speed of light, and the speed of light is only half the speed of light. Well, that's totally illogical, right? You don't even need math for that one. The only conclusion, well, and if it's an elastic collision, right, it's all going to come back. So if otherwise it'd be an elastic and just get stuck there or stick there or something. So we know that if that's at half, the speed of light is still going. So the speed of light, so what actually you'd add is the motion of the source, coming back at you, plus the speed of light. 1.5 times the speed of light. That's the only scientific conclusion you can come to, right? And Mr. Einstein said he didn't like the idea that you could add beyond the speed of light, right? When he was talking in his youth, and he had a few examples of why that couldn't be, he came to the idea that, well, that's not possible. You can't go that fast. Nothing can go that fast, right? If we were talking just basic or classical mechanics, if we had a truck going at 50 and we had a person throwing a ball at 30, would have no problem saying that an independent observer or someone in the motion line of motion would see it would come at them at 80 miles an hour. But somehow, if we did this with a mirror, like a ball or something, depending on what the percentage of the rebound would be, we wouldn't have a problem with it. But somehow, Mr. Einstein stuck with this idea that's not possible, and it's brought science back, because we need to get beyond that. Yes, it is possible. That's the way it works. That's science. That's what science says it works, right? That way, you have to let go of your prejudices, right? That something can go faster than the speed of light, or the speed of light can go faster than just c. You have to get rid of that prejudice and understand the science that's behind it. So, and the other thing I would add that I put in my first video was that the speed of light isn't holy, right? There's nothing magical about it, in a sense, right? It's just another physical phenomenon. And this is what you get. This is another physical phenomenon, and that's the way the universe works. It might take a while for people to understand that and accept it, but nevertheless, there it is. It's out there. I'm saying it's possible. In fact, it's going on all the time. We just don't know about it. So anyway, so that's that. That's all I wanted to use it for, like I said, because in my first video, I came at it in a different sense, in a different way, but the conclusions are the same. Yes, you can add the speed of light with the motion of its source to come up with a velocity greater than the speed of light. That's it. Okay, so let's move on to something else. So that was the first video. Second video is the expanding, not accelerating universe. This video demonstrates that the universe is not accelerating, but only following an expansion as first discovered by Edwin Hubble in the 1930s. The universe follows the standard path of all explosions, expansions. Detonation, acceleration, and then eventual expansion at a steady velocity. In this model, dark energy and dark matter are not necessary. So, in other words, science, this model explains just as much as those that say the universe is accelerating, but with far less baggage, right? In other words, it's not, if you go back and I do it very simply, I don't think I even have any math in it. I just go back and very simply say, yeah, the universe isn't accelerating, because that would mean it would, if it was accelerating, it would accelerate forever. That's, no, it's probably very unlikely. And in point of fact, that something that explodes and expands, whether it's a firecracker or a pipe bomb or a hand grenade or a bomb or a firework or a supernova, or maybe even the Big Bang of the universe, they all follow the same path, right? They start off with an explosion, expansion, and then they or detonation, you could say, and then they go to an accelerated phase, and then they follow the standard path of all explosions, right? They just go on, they go down to a steady velocity. That's what Edwin Hubble found. That's what it is. It's not accelerating. They did a lot of science, I've said it before, but they did a lot of statistical work, which I find extremely troubling, or if it's even necessarily true. But the universe isn't accelerating, it's just expanding. And they won not only a Kavli Award, but they also all won a Nobel Award. That was Adam Rice, or Rees, Brian Schmidt, Saul Perlmutter, and Robert Kirshner. He was the overseeing professor. And they're all wrong. I've sent this to them, but they don't get back to me on this. They're all wrong. So we'll leave it at that. Okay, number 3, the true story of the photon. This video demonstrates in several ways that a photon has mass. The mass color of light is fixed and cannot change, nor does visible light propagate in waves. In fact, Newton's third law of motion demands that a photon has mass because of opposite and equal. Based on this fact of nature, much of